Hello, welcome to another Odyssey Africa lecture. Today we're going to be dealing with linear inequalities. Alright, so in one of the lectures you'll find on the website is about linear functions. Today we're going to be dealing with linear inequalities, which are kind of similar to that. Alright, so what are linear inequalities? A linear inequality is an inequality that involves a linear function. All right. So, for example, if we have a linear function is something like this. So if you have f of x less than a, or you have f of x less than or equal to a, and you can have the same thing of f of x greater than a, or let's say f of x greater than or equal to a. Now these are examples of your linear equations. All right. Now in linear equations we have basically, so in our linear functions we use the equal to sign. All right, we use this sign, the equal to sign. So this is used for our linear equations. But for our linear functions, for our linear inequalities, what we're going to be using is our less than sign, less than greater than sign, greater than or equal to, less than or equal to. Now when you see mathematical equations with these signs, you know that they are for linear inequalities. Yeah, whatever. All right. We're going to start with some simple examples of linear inequalities. We're going to start with simple examples of linear inequalities and show you how they're done. All right. Now, so what we do for linear inequalities is we'll solve our equation, then graph the answer. All right. So look at it. Okay, let's take two numbers now. If we take, what's the relationship between 4 and 2? All right. So if we say 4 and 2, 4 is not equal to 2. Now 4 is greater than 2. So if we wanted to put this on a graph, so we have a number line graph. So we draw a number line graph here, and we'll put that 0, 1, 2, 3, 4. Right? And on our number line graph, we'll be able to make a dot here on 2 and on 4. Because, all right, so this is the relationship between 4 and 2. If we take two other numbers, so let's say we do them. Let's say we have -4 and -2. Right? Now for this, -4 is less than -2. And on our number line graph again, we're going to have 0, -1, minus 2, minus 3, minus 4. And our relationship, you can see, put the dot there for, sorry. Right, put the dot there for minus 2, minus 4. Right, okay. So this is a relationship between minus 4 and minus 2. Now let's take this into a proper example to be able to solve an equation. So for example, if we have 2x, so a typical linear equation inequality will be this: 2x minus 6 is less than 2. Right? So if you know how to deal with linear functions, we can just go ahead and solve this like a typical linear function. So in solving a typical linear function, what's the first thing to do? The first thing to do, we'll collect the common terms, right? So we have 2x less than 2 plus 6. Right, so we treat this less than sign in the middle like like you would treat an equal to sign when you're dealing with the linear function. Okay, and this will be 2x less than 2 plus 6, that's 8, and this will be x is less than 4. All right, answer is x is less than 4. So if we clear the board, our answer was x is less than 4. We'll have to graph this solution now, right? So we'll take our number line graph. Let's take our number line graph. That's it. And we'll start with 0, 1, 2, 3, 4, 5. Okay. Now there are two things in when we're graphing our number line graph for our equations. You can have an open and a closed circle to start off with. All right. So for here, x is less than 4. So we come to x. We come to. Let me change the color. So we come here. We do a 0 there, and we draw our line. Now we have an open circle here because x is less than 4. That means 4 is not inclusive in the possibilities of our unknown x. Right, so our x could be 3, it could be 2, it could be 1, it could be 0, it could be minus 1, but it could not be 4 because x is less than 4. So we, in our number line graph, we draw our open circle here and draw our arrow towards towards the area that shows x less than 4. We don't draw it towards the area which is greater than 4, obviously. All right, so let's deal with another solution. All right, in this one we're gonna deal with equation 5 minus 3x less than equal to 13 plus x. Again, we'll treat this like if it's we treat the inequality sign in the middle as if it's an equal to sign. All right, so we'll just solve this equation the way we'll solve a typical linear function. All right, so with this we'll have minus 3x minus x less than equal to 13 minus 5, and for this we'll have minus 4x less than equal to 13 minus 5 is 8. 8. Alright? Now, if we multiply both sides by minus 1, and we'll be able to have x less than equal to minus 2. Okay, so now let's see. I'm sorry. Well, if we multiply both sides by minus 1, the sign in the middle switches. The sign in the middle switches. So x is greater than or equal to minus 2. All right. Because of the minus sign, right? Because of the minus sign, we multiplied both sides by minus 1. And when we do that, when we multiply both sides by minus 1, we change the direction of the inequality. Okay? So that's why this has gone from a minus 4x less than equal to 8 now become, so when we solve that, that becomes x greater than or equal to minus 2, because we multiply both sides by minus 1, changing the direction of the inequality. If not, if we didn't do that, we'll have a so answer is x less than to minus 2. If we didn't multiply both sides by minus 1, we'll have something like this: minus x less than equal to 2, which is not right. So if we have to multiply both sides by minus 1, it gives us this. We change the direction of the inequality when we multiply by minus 1. Okay? Right. So let's go back and now draw. Let's go back and draw our. Let's go back and draw on our number line graph. On the number line graph. Now this time we do not have we don't have a less than or a greater than sign. We have a greater than or equal to sign. So what we're gonna do on our number line graph, we're gonna have minus 3, minus 2, minus 1, 0, 1, 2, and so on. On our number line graph this time around, we're going to have a closed circle. So we're going to have a closed circle. We're going to have a closed circle, and we'll draw it towards greater than minus 2 sign. So this is our x. So x greater than or equal to minus 2. Okay. Let's deal with one more example. So for our next example, we have 3 into 2x plus 4 greater than 4x plus 10. Again, we'll just be able to factor this out and give you 6x plus 12 greater than 4x plus 10. And this will give us 6x minus 4x greater than 10 minus 12. And this will give us 2x greater than minus 2. So x greater than minus 1. Okay, now let's do this on our number line graph. X greater than minus 1. Have our graph there. Minus 2, minus 1, 0, 1, 2, 3, 4. This time around, we'll have what? An open circle. We'll have an open circle because we do not have a greater than and equal to sign or less than and equal to sign. We have just a greater than sign. All right. So start from -1 down. Okay. Now, what this mean is when you have so when you have a greater than or equal to sign, it means that the number is inclusive. The number is inclusive. So we had x. If we had x greater than equal to -1, it means that x could be -1, it could be 0, it could be 1, it could be 2, and so on. Right? Includes -1. But if we say no, this is just greater than sign, it doesn't include the -1 anymore. It just includes 0. It just goes 0, 1, 2. So that's why so the way we separate this on the number line graph is with an open and a closed circle. So for a greater than or less than sign on the number line graph, they are expressed with an open circle. All right. But for this or this, they are expressed with a closed circle. All right. Right, cool. Now, we're just going to touch on one last thing before the end of today's lecture. We're just going to touch on compound linear inequalities. So these are linear inequalities that deal with and then, well, and or. All right, and or. These are linear inequalities that deal with and or. All right, so we're gonna let's look at one equation. So let's look at one equation for you. So you can have something like this: 3x minus 9 less than or equal to 12, and 3x minus 9 greater than or equals to -3. Two equations. And so these are two equations. So let me write that clear on the board. Okay. Now, what we're gonna do is we're gonna solve these two equations independently, then combine their answer at the end. So let's first deal with 3x minus 9 less than equal to 12. So for this, we're gonna have 3x less than equal to 12 plus 9, and this is going to give us x less than equal to 7. Okay, now for this other one, 3x minus 9 greater than or equal to -3, this is going to be 3x greater than or equal to 6. So x is equal to 2. X greater than or equal to 2. Right? Okay. So what are our answers here? Our answers here are x less than or equal to 7, and x less than or an x greater than, sorry, x greater than or equal to 2. So it's and, so we're going to combine, which means we're going to combine these two answers. So this is, we'll read it in one go as this: x, read it in one go as this and, with our and there, but we can also write it in this format: 2 less than 2 less than or equal to x, and x at the same time is less than or equal to 7. So this is it also, this is writing it in one format. So on our number line graph, we're going to have this. So we're going to have 1, 2, 3, 4, 5, 6, 7. On our number line graph, we're going to have what this time around closed circles. Closed circle at 2, a closed circle at 7. So let me do that again. A closed circle at 2, a closed circle at 7. I will draw a line across. So our x is in between 2 and 7, and 2 and 7 are inclusive. All right. So let's get rid of this. Right. For our note, so now we have in compound inequalities, what we also have something called interval notation. Interval notation is, well, it's the way we write our graphs. Is the way we express the express what x is in brackets. So we use squares and square brackets and your normal brackets. So for this equation, when the area where we have closed circles, we will write it like this. So x in this term is going to be 2 and 7 in our closed brackets. If we had x less than, if we had x less than 2, x, if we had x greater than 2, x less than 7, we'll write it this way. We'll write it this way: 2 and 7. All right. Now, if we had, for example, if we had x greater than or equal to 2, x greater than or equal to 2, x less than 7, what we're going to do, we're going to write it like this: 2 and 7, call the brackets. Okay. Right. Okay. Now we're going to deal, now there's one, now we're going to do an or in this. So let's take an equation. let's take an equation 2x plus 3 greater than 7, or 5x plus 5 greater than 25. So this, we can just solve this easily as 2x less than 4, so x less than 2. The second one will be 5x greater than 20, so that's x greater than 4. All right, so our things are x less than 2 or x greater than 4. So for this thing, this is where something called infinity. So this is where the infinity number comes in, which is denoted by this sign. Sorry, infinity. So we have infinity and minus infinity. All right. Now so for this one, x less than minus 2. So which means x could be 2 and could be anything. So x could be 2, it could be 0, it could be minus 1, it could be minus 4, it could be minus 100, as long as x is less than 2. So for this x goes up to minus infinity. And for this x greater than 4, and for x greater than 4, x could be anything. It could be 10, it could be 100, it could be anything, as long as it's greater than 4. All right, so let's do our number line graph for this, and our notation is going to be a little different. Well, firstly, let's do the interval, the let's do the number line graph first, actually. So here we'll have a number line graph. I'll start with 0, 1, 2, 3, 4, 5, 6, 7. Right. For a number, so this we're going to have open circles. So we're going to have open circles at 2 and at 4. And for this x less than 2, so this is our all. All right. Now, well, for drawing our notation, we're going to use our curly brackets. And for this, x goes up to minus infinity. We're going to have minus infinity and 2. And for this, x is from 4 to plus infinity. So these are our notation. So, all right. So if we had the sign greater than or equal to there, our bracket here will be square. Will be a square bracket. Same thing here. If we had that, our bracket would be a square. Will be a square bracket. Okay. Right. This is it for all the for on linear inequalities here. So next on linear inequalities, we're going to deal with word problems that lead up to linear inequalities. That's the next stage of linear inequalities that we're going to deal with. So keep looking on the Juicy Africa website. There are going to be more lectures there. If you have any questions, please just go to the student request section, post your question there. One of the teachers and one of the many people who are helping and contributing to Juicy Africa will answer your question. All right. Thank you very much.